The average BMI for dogs is 17 with a known standard deviation of 3. This was found from a sample of 64 dogs. Okay, but now what we want to do is we want to determine the sample size to estimate the mean within 0.5 at 90% at 99% confidence. Determine the sample size to estimate the mean within 0.5 at 99% confidence. That first sentence is still the same. The average BMI for dogs is 17 with a known standard deviation of 3. This was from a sample of 64 dogs. The question is, what's the sample size I need to estimate the mean within 0.5 at 99% confidence? So what's my error? My error I'm willing to accept is plus or minus 0.5. Okay? 99% confidence is what I want. Okay, so how do I crank this out? The number that I need, n, is simply the square of my z-score times my standard deviation divided by my error quantity squared. Appropriate z-score times the standard deviation divided by the error all squared. So we have to find that z-score. So we want to be 0.99. So that means this has to be 0.005. This has to be 0.005, right? Because I have to sum to 1. So now I have to find this z-score. What is this z-score? Inverted norm. 0.005. I think that's 257. Someone check me and make sure that's right. All right. So this then is 2.57 times the standard deviation, which in this case is 3, divided by the error all squared. And that is going to be 7.71 divided by 0.5 quantity squared. It's 3 times 2.57, 771.
That's not faster than we can do. Yes, it is.
All right. So I divide that by 0.5. That is 1542 quantity squared. Check and make sure that's right. All right? All right. So then I square 1542. Good. So that's 237.78, right?
Yep.
So how many do I need? I need 237 plus one more. No matter what you get, you round it up. Don't miss that. You lose a couple points if you don't give me 238. So if after we crank that out, we got 237.1, the answer is 238. If you get anything after that decimal point, you round it up. Is everyone okay on that? All right, should we take a 5-minute break or should we keep going?
Right.
Want a break?
No.
All right, we'll take a quick break.